tecnologia,
inovação,
cibersegurança,
soluções IoT e inteligência artificial.
Tudo isso e muito mais sobre transformação digital e tendências do mercado
Você encontra aqui
no Macnicast.
Yonatan, thank you for coming and participating in this talk. Could you please introduce yourself, tell everyone a little bit about yourself?
Yes, thank you very much, Fabio. It's a pleasure being here. So my name, as you mentioned, is Yonatan. I'm working in InnerEye, which is an Israeli BrainTech company, and I work there for almost 3 years now. I'm an AI developer, and yes.
Right. So your background from university is that AI from the beginning?
No, so I started with my bachelor degree is biomedical engineering.
Okay.
Yeah, and then I've majored in my second degree in like electro-optical engineering, focusing on AI challenges in this field.
Okay, wonderful. And would you say the technology environment in Israel is very strong? Would you?
I think it is very developed in terms of money investment and in terms of universities. They are all very involved in this process of AI in general, and iTech in general, yeah.
So coming from a biomedical background, going into a technology company that works on the brain, it seems like the right move.
Yeah, because I've started study biomedical engineering because I'm very passionate about the human body. I think it is the best machine in the world and in the history. So focusing on this is very interesting and very emotional thing for me.
Perfect. Very nice. So when we talk about brain and technology, which is the term BrainTech, so what can you tell us about what is being done and what is BrainTech today in our context?
Yeah, so I think BrainTech is not a new term. However, it is gaining very much popularity in the last couple of years for different reasons. But I think the most people have heard about BrainTech is maybe because of Elon Musk exercises with some monkeys, doing some innovation experiments with them. But basically, most people know BrainTech because of human and machine interface. So there are some applications for maybe disabled persons to move and to communicate with their environment using their brain to the machine.
Okay, great. But InnerEye has a different take on BrainTech, a different approach to the brain. And what is it exactly?
So I think InnerEye's approach is a bit different from the previous mentioned BrainTech companies. So we basically believe that we can interpret some experts' brainwaves. We can read it, and we can improve AI application using the brainwaves of some experts people.
Okay. Well, we'll get into more details in a minute, but. If you could just summarize or give some information about InnerEye as a company, how it was formed, how long ago, and how mature the technology is at the moment.
Yeah, so InnerEye is formed 7 years ago by two professors, one from the Hebrew University in Israel. His name is Leon Dewel. So he is one of the specialists in Israel in cognitive research. And another professor from Ben-Gurion University. His name is Professor Amir Geva, and he's majoring in signal processing of the brain and machine learning.
Perfect.
So they formed InnerEye, then gathering more people.
So the beginning of the research was more towards the military side, and then now it's mature enough to reach the market.
Yeah, so exactly. The product now is much matured. We have collaborations with governments from Japan, for example, from Israel. And we also have collaborations with academias in Japan, Germany, and Israel. etc.
And in Brazil.
And in
because-
Brazil, of course.
Of course. So you're here today, and you're here this week because we are doing a very important development work with Embrapa for the agriculture side. We can talk about that in a minute, but maybe we could try and delve into more details about what the InnerEye solution actually is, what we can do with it and how it works.
So I think it's better if I just give an example.
Please.
So, if someone drives his vehicle, okay? So he drives and then he decided to stop at the traffic light, because sometimes the traffic lights move from green to red light just in a few seconds, and you don't know. Sometimes you stop, sometimes you drive. So if you think about it from an AI perspective, so there is the input, the color of the light, and there is the output, like the results. For example, if the driver stopped or driving. But this thing was accompanied by a very big process at the driver's head. Okay, he decided in a few milliseconds whether he should stop, whether he should drive. Maybe he took the wrong decision, but nobody can know it beside his brain. Okay, because then how he got the decision to drive or to stay. So from an AI perspective, again, you can only see the input and the output, which is the results. But in the middle, there is a very large process that happened, which we can get this insight by reading the brainwaves. This is actually the only way you can try to manipulate or to understand what really happened using the brainwaves. There's no such other way.
Okay. And in InnerEye's focus right now, at least the main focus is on visual data, it's on images.
Yeah, so basically we focus on two major things, which is one of them is, again, the visual context. So, but we also had some experience with audio.
Audio as well. Okay.
Yeah, by assisting doctors that listening to the lungs. So we've been able to assist them.
Okay.
And another focus is to monitor and to get human factors from a brain. So, for example, excitement, for example, concentration levels.
Right.
So this is another approach.
Okay. So here we have already like a portfolio of applications, but to try and give a more clear example of at least one of them. Please correct me if I'm wrong here, but from my perspective, we have, AI is being used at the moment and has been developed over time to identify visual patterns, to recognize objects, and in some cases, the AI available in the market is very good. So you can identify, for instance, objects or cars or bicycles or animals or even people pretty well. But there are some pattern recognition needs that the current AI is not able to fulfill. And at the end of the day, you end up needing a person, a human brain to help with the process, with the final decision or the final identification, classification of that particular image. So, for example, in, let's say, visual inspection in a manufacturing plant. So it is possible to have cameras and AI to identify if that particular piece or that particular product was well assembled. But in some cases, we cannot get away from having a human at the very end. And probably this human is someone very experienced, someone with years and years of experience that can look at the object and say, this is ready, or I'm going to reject this because it's not good enough. And the AI, traditional AI, is not ready for that kind of decision making yet. And that's where InnerEye can bring value to the process by actually using something like this. Do you mind showing what this is?
Yeah. So this is our sensor. This is an EEG electrodes. We have 7 electrodes here. You connect it to someone's brain, and then you can easily read these brain waves.
Okay.
Yeah, and easy as that. Yeah.
So this is not InnerEye's product.
No, we are a software company, but this is not our.
So you work with several models.
So we work with several models. We have also different headsets, like different wearables. We have also like headset reminds of the Beats headphones, if you know them, and they can work with Bluetooth. So we have a lot of types of headsets.
Okay.
Yeah.
So in the previous episode of the Macnicast, where I was talking to one of the researchers at Embrapa, which is the largest agriculture institute for research in Brazil, and we were talking about exactly applying InnerEye's technology to a problem that they have. And the problem they have basically is they have diseases in plants all over the country in different moments of the year, the seasons, and literally millions of farmers, but only a handful of experts at Embrapa who can actually help them identify which disease we're talking about and how to treat it. So InnerEye can help by improving an AI algorithm using the experts' brains to scale that knowledge and scale that experience into a piece of software, a machine that can be offered and accessible to every single farmer in Brazil and hopefully in the world. But can you tell me a little bit about the work that has been done so far?
Yes,
with the team?
If I may, I would like to also emphasize the thing we discussed before. So we can roughly divide the AI application to three major sections.
Okay.
Where we have the section where you can just use AI, which not so difficult challenges. Okay? Then there is a more range of more difficult and more challenges AI, and we have the chaotic range. Okay, so we have like three different ranges for AI, and we are really focusing on the range where the challenges in AI are very big. And this is also in Embrapa. As you mentioned before, just developing an AI application for identifying or classifying sickness in plants, especially here in Brazil, it is very difficult because there is a lot of different plants. There are a lot of different sickness and their combinations as well. So although everybody likes to think that AI is perfect, it is not perfect, and it's almost impossible to develop such an AI because you need a lot of images, examples in order to train these AI models. And this is exactly the place where you need a human. There's no such way. I mean, you have to have them. And that is exactly what we did with Embrapa, because we had two experts, plant pathologists.
Yes.
Yeah, so we had
right.
Two plant pathologists from Embrapa. And what we basically wanted to do is to use their brain into the AI. Okay, we wanted the AI machine that we developed, we wanted to be influenced by the Embrapa experts.
So the expert wears the sensor, and then what happens? He gets exposed to images of...
Yeah, exactly. So the expert wears the sensor, and then you're rapidly seeing a lot of images of plants.
How rapidly?
3 times a second. So 3 images per second.
Per second.
Yeah.
Okay. So how does he have time to decide whether that plant is sick or not?
So basically, because he's an expert, he doesn't think about it. Okay, you can just see a reaction in his brainwaves. You can clearly see it when he sees something we call a target. Okay, which is a sick leaf in the case of Embrapa as experts. You can just see a very clear brain reaction. And then our algorithm can detect it. And this is exactly when we come into play, because then we can use the brainwaves of the experts and to influence our AI.
Okay, so even from a labeling standpoint, is already a revolution, because if you do labeling in a traditional way,
Manually.
you have to do it manually.
Yeah, you have to do it.
And you're going to spend, if not minutes, at least seconds on each image to try and identify what it is, and and then give some sort of result. And in using InnerEye, I can label automatically without doing anything because I'm just looking at the images. Obviously, I have to be the expert on that, but and at 3 images per second. So it's a huge gain of performance on this side.
Yeah. So exactly as you mentioned, it is the speed is increased. But there is another aspect that we should discuss about it, which is not only the speed of the labeling, and it is also what I've mentioned before. When the expert, for example, of Embrapa, see an image and he manually, let's assume he's manually tagging it, we can just see the results, if the leaf is sick or whether it is not sick. But when you use the brainwaves, there is some type of uncertainty, okay? Because the Embrapa experts are not 100% sure everything is or sick or healthy. It's not a dichotomic problem. Our brain doesn't work this way.
Okay.
We have some, we think maybe it is sick, maybe it is not sick. And then we can interpret it from the brainwave, this type of uncertainty, which is much more efficient than manually labeling. Because again, we get an insight into the brain of the expert.
Okay, that's fantastic. So you can do with that with more than one expert and feed more than one experience into the same algorithm. Does that give you more or better results?
Yes. So again, as I mentioned before, we can do it with a panel of experts because in most problems in the world, if you take 100 experts and show them an image of something, okay, again, let's take the Embrapa example of a sick plant. Maybe 70 experts will say it is sick and 30 will say it is not sick. So, there is always these aggregations between some experts, and we can interpret this using our panel of experts.
Okay, so the final result in the end is an algorithm that is closer to the human way of thinking than the regular traditional approach of AI training.
Exactly.
Wow, that's really good. So talking about other applications, so if we just talked about identifying, classifying diseases in plants, because we need experts to do that, so we can tap into their brain and automate the process and scale it. But which other markets or applications we can see this in action and actually adding value, impacting the business?
Yeah, so I think for me the most impressive application is for airports.
Okay.
Because every time I go to the airport, I think nothing has changed there for the last 20 or 30 years.
Mm-hmm.
And it is the same thing for 30 years. And this is because it is very difficult to insert AI into the airport for obvious reasons. So our application basically reads from computer vision from the X-ray machine, okay, for the luggage. Okay, so someone come to the airport, put his luggage, and then there are experts who needs to understand whether we should open the luggage, some dangerous stuff, or just things that are not allowed to take onto the airplane. Suspicious stuff, yeah, of course. And if you think about it, it's very ineffective because there are such many people, such many places you need to do it, right? For example, in Heathrow Airport, you have like 100 different stations. It meaning 100 different screeners that have to look at the images of the X-ray of each person's luggage, which is, again, very ineffective. And we don't like this in 222, yeah? We like things to be quickly.
Yeah, and the other thing is the experience of each one of those screeners might be different.
Yeah.
And it's not easy to have like 100 experts in suspicious objects for X-rays.
Yeah.
So you're bound to have some of these experts that are better than others.
Yeah, exactly.
Okay.
So our application basically using a computer vision for the X-ray analysis. Okay, so we can identify whether luggage should be open or not. However, of course, this is very challenging as we discussed before. So we believe again that the solution is using an expert, which is a screener. But instead of having 100 screeners, for example, we have one screener who gets the X-ray images from all stations. You can see it rapidly, as we discussed before, 3 images per second, 4 images per second. And according to this, we can read these brain waves and understand whether you see a threat or not, or something you cannot take into the airplane or not. And then we basically combine the decision whether we should open the luggage or not, if there is something dangerous or not. So we combine it from the computer vision and from the human experts. So this is something, again, revolutionary, because the decision is taken both by the computer vision and the human experts.
Wow. Okay. In real time.
In real time, yeah.
Okay. Very interesting. So some other applications, medical is also a very obvious application, because the experience of the doctor is always extremely valuable to the detection of a disease. So the same way we're talking about plants, we could be talking about people. Surveillance on the security side. So also we count on, many times the public sector and private sector count on experts to identify suspicious behavior. So it's also something that can be used. What else? Visual inspection in general for maybe for manufacturing plants.
Yeah, and also very important, as I mentioned before, the monitoring of the human factors. They play a crucial role, because
Right.
if you have a doctor, I don't know how it is in Brazil, but in Israel, doctors can work 20 hours shift.
Right.
So if you need to do a surgery now, you may make a mistake. But if you wear the EEG, our product, we can basically extract online your factors, whether you're very tired, you're not concentrated, and then we can online we can alert you and you say you're not concentrated or you're tired. Maybe you should, I don't know how it is in surgeries,
Right.
but like we can alert the doctor.
So that's a different type of product.
Yeah, exactly.
It's not related to AI, but it's actually able to, in real time, collect accurate data about the mental state of the operator, of the person. So it could be a doctor, but it could also be a driver. It could be a worker in, let's say, in high altitude. So anything that is dangerous or critical, we could definitely monitor that in real time and even make decisions of maybe you should not be doing this because you haven't got the right mindset at the moment.
Yeah, exactly. And again, I'm emphasizing again the fact that these factors can only be taken from the human brain.
Right.
It cannot be taken from anywhere else, because when you're tired, you're not aware of this. You're just tired.
Yes.
So
That's a good point. So a very exciting. Obviously, from Macnica's standpoint, it's very exciting to be working with InnerEye and promoting this technology to different markets. And I'm personally very excited in seeing how much we can impact the world with this new technology. So thank you for coming all the way to Brazil. I hope you've been having a good experience here, and also thank you for helping us with the Embrapa project.
Yeah, thank you for having me. It's been an absolute pleasure for me. I've enjoyed every bit of Brazil in general, and
Fantastic.
Of course from you, Macnica.
Thank you very much.
Tecnologia,
Inovação,
cibersegurança,
soluções IoT e inteligência artificial.
tudo isso e muito mais sobre transformação digital e tendências do mercado
Você encontra aqui.
no Macnicast.